All right, good morning, everybody. Welcome back to another live stream. Apologies for starting just a little bit early today, 10 minutes early. I've just got stuff that I want to get done before lunch, like mowing the lawn, so I thought I'd start just a little bit early today. And I think the first couple of minutes will be a little bit of a recap anyway. As always, these streams are recorded for you to be able to watch back at whenever you'd like, either on LinkedIn or YouTube. So even if you missed something in the beginning here, you can always just scroll back on one of those platforms. So anyway, apologies that it's been a while since we've touched MLflow. In our previous stream, we had covered the traditional ML side of things. So today we're going to talk about the generative AI side of things. But before we get into the generative AI side of things, I do want to do a little bit of a recap on some of the things that we touched on in the first stream, since they're going to be applicable to this stream. Now, I'm not going to do a full recap of everything that we covered in that first stream. The first stream, if you missed it, largely, though it was a focus on traditional ML, we also did cover like the basic like architecture and whatnot of MLflow. And so I definitely encourage you to go back and check all that out, as that will be largely informative for today's discussion. But just because I do know that there were some, like a couple of very particular things that were touched on in the last discussion, we're going to touch them on the discussion. So this discussion today here. So what we're going to be talking about today specifically is, because there's just too much content to cover as part of one stream, we're going to touch on how do I want to approach this here? Let me just go ahead and share my screen and kind of show from the MLflow documentation what we'll be covering. All right, so let me go over to the MLflow documentation. So this is the front page for the generative AI side of MLflow, and so you can kind of see like the various things that it can support. So I actually think it's probably most helpful to focus on these core component things right here. So you see tracing, observability, evaluation monitoring, prompt management, and the AI gateway. Now these first two here are the things that we're not going to be touching on today. We'll cover those probably in the next stream. I don't know if this is going to end up being a two-parter or a three-parter in terms of covering the generative AI content, but we'll focus those on the future stream. But just to, if you followed along with me with other streams before where we've built simple AI agents before, or we've touched on like OTel before, then these concepts of tracing and evaluation or monitoring are not going to necessarily be new to you. And the reason that, so I'm going to focus today specifically first on the AI gateway and then on the prompt management and optimization. Now, they don't call it this. I call it the prompt registry just because that's how my mind kind of works or like thinks about things here. But the reason we're going to focus on these two today is because these are going to serve as the backbone of circling back around to these other pieces, as like these two pieces down here will actually support these other components up here. And it's more so like if I were to kind of like outline the order in which I'm going to be covering these in, it'd be first AI gateway, second prompt management, third tracing and observability, and fourth evaluation monitoring. So it's okay how they've delineated it out here. I understand why they've done that, but we're going to focus I guess what I should say also is it's not necessarily imperative to have the prompt registry or the AI gateway set up to use these top two capabilities here, but I still kind of want to show, just for cohesion's sake, like how all of these things kind of play together. So let's first do a little bit of a recap on some of the content that we covered in the last stream, because it's going to be informative for this stream. So as always, like if you want to follow along with all the code that I am working in, so this is the repo that I have created. It's called MLflow tutorial. And then you can see here in this README that it kind of gives a conceptual overview of all the things that we'll be covering. But what I want to focus on specifically is first the MLflow architecture. So just as a reminder, the way that MLflow works is basically, so you have like, there are three flavorings of the architecture here, the right side being probably the most robust of the three, where essentially on the back end you have you have a server, and the server would be the thing that you interact with to actually interact with MLflow, generally speaking. And then the tracking server is generally backed by two different components here. You have the cloud storage, or it's depicted here as cloud storage. It doesn't necessarily need to be cloud storage. I would say object storage is probably more appropriate here, and you could see that this is kind of represented by an S3 bucket, since an S3 bucket would probably be the most appropriate here. Oh, I guess one thing I should touch on as just a reminder, and is that MLflow is an open source library that is supported and created by Databricks, and so largely MLflow has a lot of correlative features and capabilities to Databricks. In fact, I would say the only real difference between MLflow's as it manifests on Databricks versus MLflow as it manifests in open source capacity is just the user interface. Largely, by and large, the capabilities and the features that support MLflow are also supported just in Databricks very similarly, if not the exact same. It's just that the user interface on Databricks looks completely different than the open source MLflow. But generally speaking, if you understand how MLflow works from an open source perspective, then you can kind of draw correlates to Databricks. And so the reason I note that is Databricks, you have to manifest it on a cloud platform. Generally, I think the three cloud platforms it focuses on are AWS, Microsoft Azure, and then Google Cloud Platform. So if you think about using AWS as a backend, so like the Unity catalog and such for Databricks largely uses like S3 buckets as that storage, which makes sense here. Then why we would leverage this as our artifact storage here for the open source version of MLflow. And then in terms of things like tracking metadata and whatnot, then you can see that it is backed by a database. Now, for our purposes, we're not going to get super robust here in setting up like this full thing here. Instead, as you might recall from the previous stream, we're going to be using probably more of this middle path here. And what this middle path here is essentially standing up, so you can see as the name implies, so we're doing everything locally today. And then instead of having like our artifact storage be represented by like this, like an S3 bucket or something like that, we're just going to be making use of our local files as the backend storage. And then when we actually start up the MLflow server, you may not see it behind the scenes, but what it's actually doing is it's starting up I think it's oh my gosh, I'm struggling to recall it off the top of my head. I think it's a SQLite database behind the scenes here. And the reason that's important is like, so we're actually going to be making use of a feature within, or a capability within, I'm trying not to use the word feature because I know the word feature can be confusing when you think about like feature store versus like a feature as a capability. So I'm going to try to use capability so we're not getting those two confused. Not that we're doing anything with feature stores today. I'm just trying to do that for my own best practices. So, or not my own, well, what am I trying to say? My own, trying not to confuse things, I guess. But anyway, so like we're actually gonna, like, you can actually store data sets as part of MLflow, and we'll demonstrate why we're going to be using that later on in the stream today. So that's kind of a quick refresh on the back end of our architecture of MLflow. So let's go ahead and jump into MLflow, the UI, just to kind of refamiliarize ourselves with parts of it. So I am going to open up Ghosty. So by the way, I am testing out Ghosty these days. I haven't necessarily committed to whether I like it or not. I just noticed that people are starting to gravitate toward this more, and I've been an iTerm 2 user forever. I think I like it. It's just, I mean, I don't think I'm an advanced enough user to really understand like the true capabilities of what Ghosty offers. But anyway, it functionally speaking serves the same purpose as like what I've used iTerm 2 in the past for. So I'm gonna make this a little bit bigger so you can all read that better. So I'm gonna go into my repos. I'm gonna go into my MLflow tutorial. I'm gonna turn my virtual environment on, and then to start up the server, I'm gonna say MLflow server, and I'm gonna host it on port 5000 here. All right, so this is going to start up, and now you can see, so that this is what it was referring to, is that it is using, I thought it did note something in here that it was using, oh yeah, there we go, SQLite as the database. So let's go ahead and open up the MLflow user interface over in our browser over here. So just as a reminder, so you can see here the MLflow is largely segmented across traditional or generative AI, and then traditional like ML here. So this is what the side of the house that we focused on things on in the previous stream, where we were actually saving things or demonstrating how we could capture different information through experiments. And that's the thing I want to touch on here is recall here that experiments are not necessarily what you think they are. An experiment is largely a logical container to hold information. It's not like, when I think of experiment, I think of like you're comparing something to something else, and that is not necessarily the case with MLflow. And I think, as I described in the previous stream, that the reason for this is that maybe like in the early days of MLflow, that experiments were largely used as like that thing that would hold like A/B testing results or hyperparameter testing results only. And then as MLflow has grown over time, it's just kind of become this general purpose container to hold different things. So that'll become evident why I'm drawing that distinction here, hopefully in a little bit. So just as you can recall, so we trained a number of different models, and then we saved all these different results out as these throughout the runs here. And runs aren't as important for today's stream. They might become important again in the next stream, so I'm not going to cover them too much here. So I think that's all I want to do in terms of the recap. Let's go ahead and start to jump into things in terms of the new content that we want to cover for generative AI. So like I said, we're going to focus on the AI gateway and the prompt registry today. So first, let's cover the AI gateway. So let me go back in over here. So this is like the home of the AI gateway. So now let's just go into the AI gateway. And so let's talk about what the AI gateway is at a high level. If you recall, about a year or so ago, I did a stream on Light LLM. And what Light LLM was essentially doing was it was serving as this centralized gateway for anybody to be able to call like whatever sort of model that they wanted to in a seamless kind of fashion, where it would, you don't necessarily, like, instead of you having to figure out all the different credentials for all of the different respective APIs, let's say like you're wanting to invoke OpenAI or you're wanting to invoke Anthropic, instead of the user having to manage those all on their own, then they could do it through a centralized location. And so the AI gateway here largely serves that same purpose, where we can actually set things up where as a single user, I can invoke the AI gateway here, and then I'm not necessarily, as the user, having to expose any sort of AI credentials multiple different times. And then I can also do a couple different extra things with it. So you can see here that I've not actually created anything in the AI gateway yet. Now, one thing I want to touch on here is, as of today, everything must be done in terms of setting up the AI gateway through the user interface. I personally like to lean toward doing things in a more programmatic way, and I tried figuring out the best way forward for that. Basically, that doesn't necessarily exist. So what I've actually done here is I opened this issue up to MLflow on a proposal for what a programmatic administration of the AI gateway might look like, and I am tempted to kind of just maybe do this myself and see if I can actually write the code and such for like actually enhancing this so we can do a programmatic administration. Now, I'm not committed to this necessarily yet. I opened the issue about 8 days ago because I wanted to get feedback from the MLflow supporters to see if there's, because I don't want to be naive to think like maybe there's a reason why this doesn't exist. I did extensive research. I can't find a reason why this doesn't necessarily exist. So it may be that I may come back and actually do an open source contribution to MLflow here and write this code myself. But anyway, that's kind of beside the point. So let's focus on the user interface today. So how do we actually go ahead and create endpoints? So it's as simple as clicking this create button. And then hold on just a second here. I am going to, I gotta pull up some notes here on my other screen. So the first endpoint that I want to create is just a GPT-5 for Nano endpoint. So I'm gonna say because we're not necessarily trying to demonstrate anything super robustly today, and so I'm trying to save on cost here just by leveraging the Nano version of the model. So I'm gonna say name of this model is OpenAI GPT-5 for Nano. And then I am going to enable usage tracking. So we'll talk about usage tracking here in a little bit. So this is one of the cool things that is offered right out of the box with MLflow here. And then we can actually search for our various model providers. So you can see it actually supports a lot of different model providers right out of the box, including if like we talked a little bit about Light LLM before, and the reason that we were using Light LLM in that previous stream is like I was interested in hosting models locally through MLX, and so I wanted to see if there was a way to programmatically expose MLX in a seamless kind of way alongside like the OpenAI models or Anthropic models. So it is supported here, but we're not going to necessarily touch on that today. But we're going to focus specifically on Anthropic and OpenAI. So I'm going to go ahead and create my OpenAI endpoint. Now you can see here, let's get past this model section for a little bit, just a brief second here. You can see that we can actually load in our API key here, or we can use an existing API key. Now, because I've already set things up previously already, I can actually just go ahead and select my API key here from this dropdown. And you can see it has masked my key here. And now we can go and select the model. Now, this is kind of a cool interface, and I'm not really sure how they're keeping things up to date here. It does appear that it is doing some sort of programmatic fetch from the internet because, just hypothetically, let's say well, I'm probably gonna have to refill this back in, but yeah, I'm gonna have to refill this part back in. Okay, I was just curious about something. But you can see here that it's got Claude Sonnet 5 in here. Now, I am running MLflow 3.14.0, and I have not updated MLflow in the last couple days, which means that, because Sonnet 5 was just released, like, I think on like Wednesday of this week or Thursday of this week. And so somehow it programmatically knew that Sonnet 5 was available. And then you can see, well, let me go back to OpenAI. So I'm going to go back to OpenAI. I'm going to use my existing API key as we were just talking about. And you can see all the different options for models that we can use. And it's kind of cool. It's got some information about like pricing expectations and whatnot. Now, I don't know how perfect this is. I don't know if it recognizes for like, for example, we're going to be using Nano here, obviously. So per 1,000,000 input token cost is 20 cents. Does it know, like, if later today OpenAI said 1,000,000 input tokens is 25 cents, would MLflow recognize that? I don't know. And I call that out because it actually will track costs for you, and we'll see how that kind of tracks costs here in a little bit. So you can't really see it because of my face, but there is a blue select button. Here, actually, let me just move my face out of the way. So we can click this blue select button right here to select the model that we want to use. And that is all we necessarily need to do to actually create the endpoint itself. Now, we can actually do a couple cool things with the endpoint if we'd like. So you can actually see that we can directly invoke this from the browser and I'm going to do that really quick here just to kind of show how this works. But we're actually going to hop into a Jupyter Notebook and demonstrate how we can actually invoke this model from something like a Jupyter Notebook. Excuse me. Okay, so I'm going to go ahead and how are you? I'm going to say, what is capital of Illinois? What is the capital of Illinois? Send request. And then we should be able to get an appropriate response back. And so you can see, yes, we did get the appropriate response back. This is the full JSON call, but if we scroll down to the content section here, we can see that the capital of Illinois is Springfield. So that worked. But what I want to show here is, now we've just done a single invocation right now, but we can actually go up to this usage tab and the logs tab and actually start to see, or I think we should see how this worked in action. So actually, let's start with the logs tab here. So this would capture the full trace sentiment. It looks like, okay, so something that I was not necessarily expecting here. You might be wondering, why are there so many different traces here when we just created this endpoint? Well, as I was doing my testing, I had called this endpoint the exact same thing, and then I deleted it just for the purposes of recreating it for the stream. So it looks like MLflow behind the scenes is preserving all of the logs and the traces and such from what I was working on before, which is a surprise to me. I wasn't expecting that. But anyway, you can see here at the very top here, the request of what is the capital of Illinois, and then and the response here. So that is one of the nice features. Excuse me. Oh, sorry about that. Anyway, so you could see that the full trace was captured here, and that we have I believe, so we have this token column here. I believe that's the number of output tokens. I'm not exactly, oh, well, I guess we can mouse over it. I did not realize that. It's actually a combination of both. So you can see that the total input and output token time, you can see that the execution time, and then if we actually drill down into here, we could probably even get more information about how this was called. And so that's pretty cool of how this is all just captured right out of the box for you. Very simple. And you can even see, well, you can't see because my face is in the way. Let me move my face out of the way. That it estimated that this cost here was fractions of a penny, like 0.0005019. So that's pretty cool. And now we can actually do kind of something similar here of where we're just mentioning that cost, where if we wanted to look at the usage here, we can look at the usage over time. So it looks like, again, it did preserve some of my logs from the previous couple of my testing. So you can see that I've done extensive testing over the last week or so. You could see that we got errors and such, and those errors were actually intentional. We'll touch on those errors in a little bit here. Am I? Oh, I didn't realize that there are multiple flavorings of the nano model. So yeah, I didn't catch that. So that was an. Let me see if I can change this here. So I'm gonna do in the search box nano. I want the newer version. I'm sure it probably is for today's purposes just as performative as what we need for today's purposes, but just calling wanted to test that out anyway. But I think one of the other cool things here is part of the part of this AI gateway, or the AI gateway here, is that you can also do like a splitting between models if you want. So if you want to do have 50% of your traffic go to this model versus 50% of your traffic going to another model, you can do that behind the single endpoint here. So setting up the AI gateway is actually really easy. Now it's disappointing that we can't necessarily do that through the programmatically yet, but you can see that it's not too bad to get going. Now there's one more thing that I want to show here, and that is guardrails. So you can actually place a guardrail over any model that you're, over any endpoint that you're interested in, and you can get custom with those guardrails. Now, the thing with the guardrail, though, is the guardrail intentionally does not use the same endpoint as the one that we've created here. What I mean by that is if you want to use the guardrail functionality, you need to have at least one other endpoint that we can make use of here. So I'm going to go back to the endpoints. I'm going to create a new endpoint. I'm going to call it OpenAI guardrails endpoint. I am still going to be making use of nano here. All right, yeah, that's the one we want. Select, use my existing API key. All right, and then I'm going to go ahead and hit create down in the bottom right here. All right, so I've created the guardrails endpoint, so now I can go back to the GPT-5.4 endpoint, nano endpoint, and then we can go ahead and create a guardrail. And so the way that we do that is simply by clicking this create guardrail button, and you can see that we can, it has a couple of default guardrails. So you have one that's a safety guardrail that's detecting for each of these categories of harmful, offensive, or toxic content. We also have PII redaction, so that's personally identifiable information, so things like names, emails, phone numbers, or social security numbers, or whatever. Or you can get custom with your guardrail. So we're going to select the custom guardrail, and then I'm going to call this the Jar Jar Binks guardrail, because I like to do everything with Jar Jar Binks as my example. And so I'm just going to call it Jar Jar Binks guardrail. And you can see that we can actually apply the guardrail at one of these two phases here. We can either have it do it before it goes out to the LLM, or after it goes out, comes back from the LLM trying to redact in results or whatever. So you can see that here from the instructions, it defines how you would actually apply this guardrail. And so the way I am going to write it is I am going to put receives inputs. By the way, so this double curly braces here is how we reference input variables. Well, I guess I'm going to do it how the example says it. So I'm going to say does, I'm going to apply it to the pre-LLMs, is inputs free of anything to do with Jar Jar Binks. Answer yes if it is safe. Yes if it is safe. No if it contains anything to do with Jar Jar Binks. So basically what this is doing is MLflow's kind of, in terms of guardrail functionality, is if it's yes, then you're good to proceed forward. If it's no, then we need to do take one of these actions down here. So we can either block the request entirely with a 400 error, and so that's what you were seeing there. with those errors before is I was purposefully simulating this 400 error, or you can do a sanitization. So we're going to stick with the pure block here. Now you'll see that down here I can't create the guardrail until I've selected the model endpoint, and so that's what I was mentioning before is we have to have this secondary endpoint because it's not going to make out of the box. It cannot do like a self-referential endpoint as like its own guardrail kind of thing. And I understand why that's the case. Oops, I just realized I didn't put that there. So I'm going to go ahead and select that and then go ahead and click Create Guardrail. Now I'm going to go back here and then let's go ahead and test this out again. So I'm going to do try in browser. I'm going to say, what is the capital of Illinois? Answer as Jar Jar Binks. So what we should expect is because we're doing anything with our Jar Jar Binks that we should get a block. And so let's see what happens here. So I'm going to do the send the request. Now it should be going through the guardrail first, the guardrail LLM, and then doing that check. I don't know why it's taking so long. Okay, there we go. It did catch that. So you can see here from the response that the guardrail, the Jar Jar Binks guardrail blocked it, and the input was to answer as Jar Jar Binks, which directly involves Jar Jar Binks. Therefore, it is not free of anything to do with Jar Jar Binks. So, and then you can see that we got a 400 bad request here. Great. So we demonstrated that the guardrail is working appropriately. Okay, so we went ahead and set up one endpoint here with oh my, I'm drawing my brain is just not functioning right this morning. I'm a little bit tired. I don't know if you all had a good 4th of July, but like the fireworks here were just going off like until midnight, and I'm normally in bed by like 8:30, so I'm a little bit sleepy this morning. Okay, so let's go ahead and create another endpoint here for Anthropic. So I'm going to call this Anthropic Claude Haiku 4.5 endpoint. We're going to go for Anthropic. I'm going to search for a haiku. We're going to use this version. And then we are going to use my existing API key. So I've already plugged in my Anthropic API key here. So I'm going to go ahead and click Create. Now I'm going to apply a different kind of guardrail here. I'm going to but use the Anthropic again. So I'm going to call this Anthropic guardrails endpoint. Again, I'm going to use Anthropic here. I'm going to go to Haiku, select my API key, and create. Value already. Interesting. Because I deleted this, so I'm just going to call it guardrail endpoint, whatever. All right, so I'm now going to go back to this endpoint, apply a guardrail, create guardrail. I'm going to do my own custom guardrail. I'm going to call this Jar Jar Guardrail. Now, I want to demonstrate something because I think that there might be something maybe broken with MLflow here, because I want to sanitize these questions where I'm going to say well, I'm actually going to do a post LLM guardrail. Does outputs correctly answer inputs without any reference to Jar Jar Binks? Answer yes if it does, no if it contains content related to Jar Jar Binks. Now, what I would actually expect in this case is, I'm going to use the Anthropic guardrail endpoint, is that because I'm doing a post LLM guardrail call, is that it should, like if I asked like what is the capital of Illinois and I asked it to answer in the tone of Jar Jar Binks, what I would expect this post LLM guardrail to do is to give back that answer of what is the capital, but exclude any sort of information about Jar Jar Binks. And we'll test it out, see how it works today, but hopefully you'll be able to see what I am having an issue with. Sorry, notice my stream might have cut out, but it looks like we're okay. By the way, if you are watching on LinkedIn or YouTube, I am happy to answer any questions as we go along from the chat. All right, so I'm going to go ahead and create that guardrail. All right, and so we have went ahead and created our respective guardrails. Now let's go ahead and hop into the notebook to demonstrate how we can actually programmatically invoke these guardrails from a notebook. All right, so I'm going to do a couple of imports here. So I went ahead and created a couple of like empty notebooks here, but as you can see from my GitHub repo, actually it's probably easier to look at it through here. So in my GitHub repo, if you go to notebooks, you can see that I've got two different notebooks here that we're going to be referencing today. So one of them is this AI gateway. So if you want to see like a more robust version of like how this whole thing works with like notes and everything, then I would recommend you check on these completed notebooks. But we're essentially going to be walking through this step by step on our own here. So we're going to do a couple of imports. We're going to say import Anthropic, import requests, and then from OpenAI, import OpenAI. All right, now we also need to set the base URL that we're going to be referencing. So again, we're going to be reaching out to the MLflow tracking server in order to like get our calls from the endpoint. So I need to set our base URL. So let me make this again bigger for you all, just so you can have plenty of room to read. I'm going to say MLflow base URL equals HTTP 127.0.0.1, so that's a local host. For some reason, I found that if you type the word localhost, it just doesn't work. So that's why I'm typing out the full 127.0.0.1 there. And then we're going to set the names of our respective endpoints. I'm going to say OpenAI GPT 5.4 nano endpoint equals OpenAI GPT 5.4 nano, and then we're going to set our Anthropic endpoint. So we're going to say Claude Haiku 4.5 endpoint. That's not going to get confusing at all. 5.4 versus 4.5. All right, and then we're going to do Anthropic Claude Haiku 4.5 endpoint. Now this is just a reference to the exact names that we named these things over in MLflow over here as we created them. All right, so we're going to go ahead and run that cell, and then let's go ahead and create a couple demo prompts. I'm going to say my general demo prompt is going to be, what is the capital of Illinois? Question mark. And then we're going to say jar jar prompt equals, what is the capital of Illinois? Please answer in the tone of Jar Jar Binks. Okay, so we've set, this is basically all the configuration that we need to set up. Now, when it comes to actually invoking the AI gateway, there's essentially two ways that you can do it, particularly with the Anthropic and the OpenAI models. And you can see we've already imported the Anthropic and OpenAI like Python clients, but you can do it one of two ways. You can either use the Python clients if they are supported by the model providers. So the big model providers, OpenAI and Anthropic, of course, they support them. Or you can do more of what is a general curl request, which is kind of what we did here in this notebook, where this is actually a curl request here. And the way that we use do curl request in Python is with the request library. So I'm going to demonstrate how we can do both of these. So first, I am going to say OpenAI. We need to actually instantiate the OpenAI client. Let's do things with the OpenAI and everything with OpenAI first, and then we'll demonstrate things with Anthropic. So I'm going to say OpenAI base URL equals, so it's going to look a little bit funky, but not too bad. So I'm doing an F string here. I'm going to do the MLflow base URL, but that's not enough. We also have to do this here. We have to do /gateway. So this is a reference to our AI gateway, OpenAI /v1. Now the client also expects an API key. Now in this case, it doesn't matter. So because we've actually applied the API key through the AI gateway, so we're actually going to say the API key is a dummy here. So let's go ahead and invoke this then. OpenAI client.chat.completions.create. The model is going to be our OpenAI model, and then we're going to have our messages. And then we're going to do role is user, and then our content is going to be our demo prompt. Okay, so that is invoking the model. Now let's go ahead and print out the response as well. Print response.choices 0.message.content. All right, so let's go ahead and invoke this. All right. It usually doesn't take this long. I'm not sure what is going on here. Okay, so it did it right. I'm not sure why it took so long. Usually it's almost instantaneous when I run this thing. In fact, let me go ahead and try that again, just out of curiosity. But while that's running, let's go ahead and actually just jump back into the AI gateway here and then show through here. Now, if we go back to our logs, you can see that we have these things here that are running. Now, these are the two invocations that we just did. So again, just demonstrating the full trace here. Now, one thing I do want to touch on before we get back to the notebook, before I forget, you'll see this thing here over on the left called budgets, where you can set a budget here of like, so like if I have a monthly budget of $5, then once it hits $5, then you can reject everything. So my current spend is 11 cents. Again, this is because I'm using really low or cheap models. Now, the one thing that is kind of strange about the budget policy is that this is set on the overall gateway. You can't, I can't see that you can actually set this on a per model basis. So like if you wanted to have like a budget for the Anthropic endpoint versus the OpenAI endpoint, I don't see that that is a capability today. This budget policy is just kind of a general budget policy. And this is MLflow's flavoring of it. Now, as I've demonstrated in the past before, because I'm very cost cognizant, like with the OpenAI API, and I'm pretty sure the Anthropic API supports this as well, through their own administrator backend, you can set your own budgets that way. So that's what I would probably more encourage rather than doing it through here. But I did want to touch on that is a supported capability by MLflow. All right, so we demonstrated how to invoke the OpenAI endpoint through the Python client. So let's demonstrate it now, how to do it through the request URL, or I'm sorry, as a curl request through the request Python library. So we're going to do responses equals requests.post, and this is just to give you a robust flavoring of the various ways in which you can invoke the AI gateway here. So we're going to do gateway / OpenAI nano / MLflow / invocations. So that is the URL. We're going to give JSON. It's going to be messages. And then we're going to do role user. I'm glad I wrote this all down out before, because a lot of this is just rote, like repetitiveness. Like you might be wondering, why are we breezing past some of this stuff? And it's because we've done it in the past, and trying to figure out how to call an LLM API is rather basic, and the OpenAI documentation, the Anthropic documentation is already pretty robust for that. So that's why I'm kind of breezing past some of this. Response.json. Choices 0 message content. All right, so, and then let's go ahead and run this, and we should get back a very similar thing here. What did I do? Response.json. Oh, that's right. Had a little typo there. There we go. And you can see that time it ran much faster. I'm not really sure why. In fact, let me run this just one more time, just out of curiosity. Not really sure. Okay, that one ran much faster. Not sure why the first couple times it was kind of slower there, but yeah, you can see that it's much faster now. All right, so that is invoking the OpenAI endpoint. Now I do want to test out the guardrail just to kind of demonstrate it here. So we already instantiated the client, so we're going to do this through the Python, the OpenAI Python client again. So I'm actually going to do a try except thing here, because we're going to get a failure or an error notification otherwise. So I'm going to say OpenAI equals or try response equals OpenAI client dot chat dot completions dot create, and then we're going to say model equals OpenAI, and model messages equals role is user, and then content And then we're going to do the Jar Jar prompt this time. All right, and then we're going to print the well, I would print the response, but I know it's going to fail out. So that's the reason I wrap this in a try except block, because now I'm going to get the exception and just print it out. Exception as E, print E. So what we should see here, and there we go, is that the try except block did catch this here as a failure because I was trying to ask things in the tone of Jar Jar Binks, which my guardrail does not like. All right, perfect. So now we've demonstrated things through OpenAI. Let's demonstrate how we can do things with Anthropic. It's going to work very, very similarly, so I'm going to kind of breeze through this rather quickly. Anthropic client equals Anthropic dot Anthropic. Oops, Anthropic dot Anthropic. Okay, so we need to pass in the base URL. Base URL is going to be MLflow base URL /gateway /Anthropic. And then again, we don't need to give a real API key because the API key is being managed by MLflow. So we're going to call this dummy. All right, now let's go ahead and invoke this here. So we're going to say Anthropic client.messages.create model equals Claude Haiku model. And then we're going to give messages equals, you could see this is very similar to how we're doing things from OpenAI. Role is user. And then we're going to say content is demo prompt. All right, and then let's print out the response. Print response dot content 0.text. What am I missing here? Model. Oh, I forgot you. The OpenAI models like to see max tokens here as well. Max tokens equals. Let's do 10,000. Doesn't really matter because it certainly will not hit that. All right. So, and there we go. So we have successfully invoked the Anthropic endpoint through through the Anthropic Python client. All right. So let's go ahead and show that just really quick here. All right. So we're going to go to our Anthropic endpoint. We're going to look at the logs, and you can see this is exactly what we just called today. What is the capital of Illinois? All right, now let's go ahead and demonstrate how you do things through the request library. It's going to look very similar. In fact, you know what? Just for time's sake, I'm just going to go ahead and copy and paste some of this stuff because I want to get moving on to other things, and we've already been going 45 minutes. Okay, so this is how you do things through the request library. This is going to look very, very similar again to how we did things through the OpenAI library. So again, nothing particularly fancy here. It's just making sure that you format this URL string correctly. And then finally, I wanted to show the guardrail in action. So I'm going to paste all this in here. Again, I'm just instantiating the Anthropic client and then basically doing the exact same thing that we did before. So let's go ahead and run this. And I do have the try except block here. This is the one thing where I wanted to call something out here, because my expectation is that, again, because we're doing the guardrail on the post LLM call, meaning that we want to scrub the results here, and my expectation would have been, because I'm asking for the capital of Illinois, but I'm doing it in the voice of Jar Jar Binks, that the guardrail LLM would have just simply like scrubbed that out. Now you can see here that it is noting sanitization LLM returned invalid JSON. Well, let's go ahead and look at that because, and you'll see why I'm like curious why this is not working correctly. So if I go to the guardrail endpoint and I go to the logs, and then you can see that I am a content sanitizer here, you can see, all right, where is it at? Is this the full, all right, oh, let's look at the JSON here. Messages, choice usage. All right, rewrite, and then, okay, so you can see here that it actually did return back a sanitized version of the answer here, and it's just that it removed anything to do with Jar Jar Binks. So I'm not sure why MLflow is not able to recognize that correctly, because it did work. It's just, again, I don't know if there's some sort of MLflow bug or what there, but like the sanitization actually did work. It just, didn't manifest correctly. So, all right, that's everything that I want to touch on with the AI gateway for today. So now let's move into the prompt gateway here, or the prompt registry. So as the prompt registry, Well, I guess they do call it the prompt registry. I've not seen it anywhere in the documentation where they have actually referred to it by the documentation by that name. So this is where things actually do get a little bit better in terms of being able to interact with things programmatically. So with the AI gateway, as of today, we can only set things up through the user interface. With the prompt registry here, we can actually use the user interface, or we can do things programmatically. So I'm going to demonstrate both ways. I'm just going to demonstrate first just a very simple creation through the UI. Now we're going to be creating two different kinds of prompts today, just for our demo purposes. We're going to be creating a summarization prompt, and then we're going to be doing a sentiment analysis prompt. So let's focus on the summarization prompt for now. But we're not going to spend too much time in the user interface directly here in terms of creating the prompts, that is. All right, just pulling up my notes just to remind myself what I had the prompt to be here. So you can see, first off, before I go filling out anything, you might have noticed that we have a prompt type. So there's two different prompt types here. So you have a standard text prompt type, and then you have a chat prompt type. Now, the difference between the two is, so as you can see as I toggle between these, is that one of them is basically setting things up as if it's like a back and forth conversation. So that is this chat prompt type. And so that would be very helpful for things like few shot prompting, or if you want to get specific with a system prompt. So for my purposes here, I'm going to call this UI summarization prompt, just delineating that I'm creating a prompt within the user interface here. And then you can see that, again, we can use variables here that as long as they're wrapped by double curly braces as such. So I'm going to say summarize the following text in num sentences. So however many sentences we want. And then I'm going to say, here is the text to summarize. Text. All right. Now, technically speaking, that's all we need to do here. We could just click the create button, which is kind of hidden by my face. It's right next to this cancel button right here. Let me move my face just so you can really see. But you can also see here that there are advanced settings, and we'll talk about the advanced settings as we jump into the programmatic creation in a little bit. But there's also a commit message, and the nice thing about the commit message is, so the nice thing about the prompt registry in general is that it will version your prompt. So let's say you start off with a basic prompt today, and then you find that a more refined version of the prompt is better going forward. If you still want to preserve the history of whatever that previous version was, you simply just overwrite on top of the prompt entry here for a new version. And that's where the commit message can come in helpful, because then I can say creating the initial version of the summarization prompt. And then I can click create. And then as I go here, and then you could see that I could create a new version. Well, I guess you can't because my face is in the way. But you can see that through this blue button at the top right here, then I can create a new version. Here's the text you need. Here is text I need you to summarize. I don't know. I'm creating version 2 of the prompt. And then if I go click create here, now you can see that I can go back and look at the original version, or I can go back and look at my my new version, and then I can even do a comparison here of the version 1 versus version 2. Diff highlighting is not supported in Markdown view. Switch to text view. Okay, so then you can actually see in this text view right here what exactly was modified. So that's kind of cool. And then you can see all I'm not going to worry about that. So that's how you create things in the user interface. Now let's jump into the notebook to kind of demonstrate things in a more programmatic sense. So I'm going to go ahead and jump into this new notebook here. And then I need to do a number of imports here, and these imports will become more evident as they come along. I'm just going to do all of them at once right now, and then we'll come back and explain some of these, what they're doing. So I'm going to do import JSON, import MLflow from MLflow.genai.datasets, import create dataset. This will become, again, more prevalent as we get further into stream why I'm importing this from MLflow.genai.optimizers import JEPA prompt optimizer from MLflow.genai.scores import equivalence from OpenAI. Oh, wait, I just realized I have a typo there. Import OpenAI. Now, for this the purposes of this notebook, I'm not going to use the Anthropic model for any reason. I'm just going to stick with the OpenAI model. Pydanic import base model field. And again, we will explain what these three are doing later on in the notebook, along with why I'm importing Pydanic here. So those are our imports. Now I need to set a couple of different things here, and just for time's sake, I'm gonna just copy and paste this in here, but I'll explain it again. So again, because we're making we are going to be using the AI gateway again here. So we are reinstantiating the base URL, which is just the local host at port 5000. We are setting the GPT-5.4 Nano endpoint. We are instantiating an OpenAI Python client, and then we actually also need to set the tracking URI for MLflow here, because that will help. What this is basically doing is saying, okay, anytime I run like a register prompt kind of thing, then I know that I want to do it with this very specific tracking server here, the MLflow server that we have spun up as part of this over here. Okay, so then I'm going to go ahead and import that. Now I'm going to copy and paste another couple things, only because this would take forever for me to type out by hand. And that is just a couple of prompts that we're going to be working with. So we're going to start off with the summarization prompt, and then I also have a write-up here. So let's chat through these really quick. So I mentioned as we were creating the prompt over here that there are two different flavorings of prompts that we can create. So we can create a text prompt versus a chat prompt. So we're going to create one of each of those just to demonstrate both of them in action. So we have the simple, I don't note it as text prompt. If it like I delineate chat prompt as such down here, so you can see that the chat prompt, we have the system prompt, the system level. So that is summarize the content you were provided with number of sentence, X number of sentences. And again, as a reminder, we use double curly braces here to represent variables. And then the summarization prompt here, this is the text prompt, basically the exact same content, just formatted a little bit differently. And then finally, because we are doing a summarization here, I had ChatGPT write me up a basic MLflow prompt or write-up about MLflow that we can later summarize. So not really important what the content here is, just kind of wanted to call out what this is doing. So I'm going to go ahead and run this cell. Now we are ready to go ahead and start to register our prompt. So the first, we're going to do a basic registration first, and then we're going to do a more of a little bit of an advanced registration. So this first version of the registration is going to look exactly like what we did in the UI. So we're going to say registered summarization prompt equals MLflow.genai.register prompt. All right, we're going to say name equals summarization prompt, template equals summarization prompt. So as we defined it above, there we go. And then commit message, I'm going to say registering the initial version of the summarization prompt. All right, and that's all we need to do to register the prompt in a very simple way. So I'm going to just do a print statement down here. In fact, I'm just going to copy and paste this print statement just to, again, save on time here. So what this print statement is going to do is it's going to say we created this prompt with the name, and this is the version that we want to do. In fact, you could see that. So we just created version 1 here, and you can see it's already populated in the UI, and we could see it exactly what we created here, including the date we had done this at. Now, if I ran this exact same cell again, what you'll see is that it's just going to go ahead and create version 2 here. And so you can see here that the time difference is only like, it's very slightly off. So you can see it's 01 seconds here versus 16 seconds here. So that is how things are versioned here. It's basically just referencing the exact same name of the name of the prompt that we gave it in MLflow, and then we could theoretically put whatever different sort of template here that we wanted. So that's registering the basic text prompt. So let's show how we actually do the same the chat prompt, that is. So let's do registered summarization chat prompt equals MLflow.genai.register prompt. This is going to look very similar to how we did the one above. So it's going to say, we're going to call the name here summarization chat prompt. Template equals summarization chat prompt, and then our commit message is going to be, oh my gosh, can't type. There we go. Registering the initial version of the summarization chat prompt. All right, and then I am going to just copy and paste this print statement from down here. It's going to be basically the exact same print statement that we have above. All right. So then there we go. So if we go over back into our prompts here, now you can see our summarization chat prompt is here, and you can see that it's formatted a little bit differently than like the standard chat prompt, where because we did it as a chat prompt, you can see that we actually have a system little icon here versus the user icon here. So that's kind of cool. Now I want to demonstrate things. So that was a very simple programmatic registration. I want to get a little bit more specific now, because you can actually do some additional things with registering these prompts, and I'm going to show the options in the UI, but we'll actually manifest it programmatically speaking here. So you might have noted here that we have some advanced settings. And what are these advanced settings? So let's go ahead and toggle them open. So like, let's say you actually want a very specific structured schema. We could actually create this structured schema here using JSON. So what the expectation would be. Now, programmatically speaking, we could also use JSON, or we could use Pydantic. So if you're familiar with Pydantic, I'm sure that many of you have seen me use it in previous streams. It's basically Python's way of helping to create a very structured data structure for like what you're expecting. So in terms of what we would want for a structured output, we can actually set that using Pydantic, and we'll demonstrate that in the notebook. But the other thing that we can also do here is, let's say we created this prompt and it's very specific to a very specific model configuration here. Like, we designed this prompt to work ideally with GPT-5.4 Nano, or we designed this prompt to work very specifically with Anthropic Claude Haiku. So those are some of the advanced settings of how the additional information that we can store alongside here. Now, I don't see it in the user interface here, but you actually can apply metadata tagging as well here. So we're going to do all of that, overriding the exact same prompts that we just created, but we're going to apply some of these additional things that some of these additional configuration settings on top of that. All right, so let's jump back into the notebook here. So we're going to focus first on the text prompt versus the chat prompt. So we're going to say registered summarization prompt equals MLflow GenAI.register prompt. All right, name is going to be summarization prompt. And then template is going to be our summarization prompt. Commit message, we are going to say this time registering the prompt with additional config information. So far, basically no changes from what we've done above. Now we can start to get, well, actually, I want to create a cell above this, because I want to create the Pydantic structure up here. So recall that we want a specific output format, or a specific response format. So I'm going to use Pydantic to create that, and we're going to keep it very simple. We're going to say class summary response format. We're going to be making use of Pydantic space model here, importing from that. And we're going to say summary is going to be a string. It's going to be a field with a description, summary of the content. I just realized I have a typo there. Description. All right. So now we can come back down here and we could say response format is going to be that summary response format. Now, I mentioned that we're doing things in Pydantic here, but the way it's actually going to manifest when we actually push it up to when we actually push it into the MLflow prompt registry is it's going to show up as JSON. And I think that's why whenever we were looking at the user interface here, why I was expecting a JSON schema, because it's doing the conversion for us from Pydantic automatedly here. We're going to do model config now. And we are going to say model name is going to be our OpenAI GPT-5 Nano endpoint. Now, this is not necessarily saying like you must use this prompt with this endpoint. This is more of just like additional configuration information that a user could use to understand what the ideal context in which to use this prompt. But you can still technically load the prompt back in and ignore all this model configuration information and the response format information. It's just kind of helpful stuff to sit alongside of the prompt. But not necessarily things that are imperative to be used. Temperature is going to be 0.7. Max tokens, we're going to say 1,000. All right, and then we're going to add some tags to it, some metadata tags. So I'm going to say tags equals, I'm just going to create an author tag, author, and then I'm going to say me. Again, no relevance here other than just kind of like metadata management. All right, so I'm going to go ahead and print this out. All right, so we have registered that. Now, if you recall, we actually did a registration twice above, so that's why this is now version 3. So let's go back in here, look at our summarization prompt, and you can see now that as compared to previously with our previous versions, we got a lot more information here where we have and you can see that we actually have the structured output. So this was Pydantic before, but now it is being manifested as JSON. We actually have the prompt itself. And so, yeah, so we have all this information here. Now, one thing I didn't think to do before was, as part of this notebook, was to add aliases, because you can actually add various aliases here to say this is like the OpenAI one versus like the Anthropic one, and that could be cool if like you have like, let's say you have multiple flavorings of the summarization prompt, and like but one's more ideal for Anthropic and one's more ideal for OpenAI. Then you can use those aliases when loading the prompt back in to simply reference, yeah, I'm using the Anthropic one, or yeah, I'm using the OpenAI one. But I didn't include that in the notebook. I just didn't think to. So, but that seems like it should be relatively easy to apply. Now let's go ahead and do the same thing for the chat one. And again, just because time is coming up on us quickly, I'm going to go ahead and just copy and paste this, because this is going to look pretty much the exact same to what we did above. So the only difference here again is that we're just referencing like some of the different like the chat prompt versus the text prompt, but it's the exact same otherwise. So again, if we come back into here and we look at the summarization chat prompt, then you can see that we have everything as we would expect it. All right, now let's go ahead and demonstrate how we can actually load the prompt back in and actually make use of it. So let's, just for time's sake, I'm only going to do just the text prompt, just because of the chat prompt. It's going to look pretty much the exact same way, but just trying to save on time here. So loaded summarization prompt equals MLflow .genai .load prompt summarization prompt. Okay, before I actually run this, I just want to briefly call out, you might be wondering, well, how does it know to actually call out to my version or my running instance of MLflow and loading this? So recall that we named the prompt itself, this summarization prompt, and then if we come back up here, recall that we actually set the tracking flow, the tracking URI to be our base URL of 127.0.0.1 at port 5000, and so that's how programmatically behind the scenes it knows to grab this specific prompt here. And so if I run this, and then we could do loaded, loaded summarization prompt, you can see that there's a number of different attributes associated to this here. So like if we wanted to reference, for example, the response format, the response format's in here as that, or if we wanted to look at the, if we wanted to look at if we actually wanted to format the prompt, we could do format, and recall we have num sentences equals 5, and then our text might be MLflow write-up. All right, and then you can see that it has taken our prompt and then placed in our, or it's replaced the variable names with the respective things that we just put in here as such. I'm going to call it, I'm actually going to save this as a variable. I'm going to say formatted summarization prompt equals that, and then we can actually just invoke it. Well, let's demonstrate how we can invoke it. So we're going to say response equals OpenAI client.chat.completions.create. All right, so then our model is going to be, we're actually going to load it directly from here. We're going to say .model config is going to be model name. So we're loading that directly from the loaded prompt. We're going to say messages equals, oops, that was strange. All right, so we're going to say role user content is formatted summarization prompt. Uh-oh. Man, there we go. And then recall that we have our very specific response format. So the way that we can apply that here is we're going to say response format equals type JSON schema name summary response schema, and then we're going to load up that schema from our loaded prompt with the response format there, and I think that's all we need. And then we're just going to print out the response from print response.choices 0 .message.content, and then yes, I probably did forget a comma somewhere. Yeah, I forgot a comma right after that. There we go. And it should return back a JSON schema. Okay, this is exactly what we were expecting. So we had set the Pydantic structure to produce a summary, and then we can actually see the actual summary of what was written here. All right, great. So in fact, I'm going to reduce that. I'm going to say to 2 sentences because 5 was kind of long for a summary. Let's see how it does. MLflow is an open source platform that manages machine learning, blah, blah, blah. That is a very long compound sentence with a lot of lists there, but I mean, technically it worked. And then did it do just 2 sentences? That's what I wanted to see. Yeah, it did just 2 No, it did do 3 sentences, but we're only using Nano, so I wonder if that's why. But I'm not as concerned because that essentially is like how to use the prompt. All right, so we mentioned, I'm just going to copy and paste this, like just to show the chat prompt. No, I'm not going to do that here. I'm not going to worry about that because I do want to focus on one more thing here associated with the prompt registry. And this is not necessarily a direct feature of the prompt registry, but it ties very closely to the prompt registry, which is why I want to cover it here. And that is an automatic rewrite of prompts. So imagine like going forward like that. Let's say you have like a generative AI application that's running out in production, and like maybe it's doing sentiment analysis, and it's trying to determine, is this sentence here positive, neutral, or negative? And you have a really hackneyed kind of prompt to begin with that's not great. Can we use both the inference results from like the historical like of whatever you're seeing, and then also some ground truth results to kind of do a ground truth comparison to the inference comparison and see if we can use those to rewrite the prompt in a more ideal fashion. This is very similar in concept to how DSP kind of approaches things. If you recall that from I did a stream on DSP like a year or so ago. I'd like to do another stream on DSP because DSP's kind of changed quite a bit over time. But that is essentially what we're going to kind of emulate here. So let me go ahead and paste a bunch of information here just of things that we can work with. If my copy and paste is going to work all right. Okay. All right, so I'm going to copy and paste all this information here. Now, the first thing I want to touch on here is I created a number of different sentiment examples already. So this is a set of 20 sentences all about MLflow, and they have the label associated with them of positive, negative, or neutral. Now, just for context, all the negative ones are things of that are not necessarily negatives about MLflow. It's just like user errors or like basically self-inflicted kind of things. So, because we're going to speak positively about MLflow. I actually don't have anything negative really to say about MLflow. There are different ways to do things, of course, so people might prefer one thing over another, but I don't have anything negative to say about anything negative to say about MLflow by any means. But what I want to show here is our initial sentiment analysis prompt. So you can see here, this is just a very hackneyed one that I created. I said, yo, check out these sentences, determine the sentiment. You got 3 choices, positive, negative, or neutral, and then have at it, and then here are the sentences. So very, like this prompt in theory should work, but like it's very kind of hackneyed. So I want to demonstrate how can we actually reuse or use our examples here to kind of inform what we're going to be doing to optimize what this prompt might be in the end. So the first thing I want to do is I want to register this prompt. And this prompt is going to be very similar to how we registered things already. So I am, oops, I'm looking at the wrong notes here. Okay. Wrong notes, chat prompt. All right, so the very first thing is I want to just register this first prompt here the way we've already registered the other prompts. So we have our sentiment analysis prompt. Nothing new here, just go ahead and registering that in MLflow. So let's go ahead and look that up in MLflow. So we have the sentiment analysis prompt, and we have it as such here. All right, perfect. Now, how do we actually go ahead and set up ourselves to actually do this auto rewrite? So the very first thing that we need to do is we actually need to create a formalized rewrite data set within MLflow. And that's why I wanted to touch on experimentation and MLflow experiments at the beginning, is because like MLflow experiments, again, being this logical container for various things, is actually going to be where we end up storing this data set out. So first we need to format things in a way that MLflow would expect it as we register this new data set here, and then we'll look at it up in MLflow in a second. So we're going to say sentiment rewrite records equals, all right, so we need inputs, and our inputs are going to be sentences, example, text. All right, and then we're going to do outputs, example, sentiment. Okay, and then expectations. Expectations, I want to make sure I just type that correctly. It's going to be expected response. Example, sentiment, and then below here I'm going to do for example and sentiment examples. So just to kind of walk us through what we're doing here is we're iterating over each of our sentiment examples that we've established here. So as you can see, we have the text associated with the sentence and then the sentiment itself. So the idea here is that the input would be the sentence or the text itself, and then the output would be what we'd actually seen in the past. Now, the way that the MLflow example actually writes it is like the example has you produce like a certain set of inferences with like one model and then do it again or do the rewrite with another model. I'm kind of skipping past that, and part of the problem is like I didn't want to have to go try simulating inferences versus ground truth. So you can see that the outputs versus the expected response are the exact same in this regard, which is not ideal in practice. You would actually want like human labeled ground truth ideally for a rewrite. But yeah, so like let's go ahead and actually create the data set then. So I'm going to say sentiment rewrite data set equals create data set. So again, now it's hopefully starting to make sense why we did all those imports toward the top of the notebook. Sentiment prompt rewrite data set. And then, well, I did have some tags in here, but I'm just being lazy right now. And then to actually write these up into the data set, we're going to say sentiment rewrite data set equals sentiment rewrite data set dot merge records. So we're going to merge all those sentiment records that we created above. And then let's go ahead and run this. And let's see what this actually created, because this can be a little bit confusing what I just did, but it hopefully will be more evident here up in MLflow. So you can see here that we're at home. If we go to our experiments, now if you don't specify an experiment, it just goes to the default experiment. And so you can see within the default experiment, if I go over here to data sets, that we have this exact data set that I just created here. And so then if we look inside of the exact data set, then you can see here are our inputs. And then our expectations for those associated inputs. And so this is how we are going to be able to make use of like the auto rewrite going forward, is we're going to make use of this data set here. Okay, so that is that part. Now let's go ahead and go on to actually setting ourselves up for actually doing the rewrite of the prompt. So the very first thing here that we need to do is we need to create a function that is basically going to like actually produce like the inference value, because basically what it's going to do is we're going to give it all the records and such, and then it's going to do like a guess of like what the sentiment should be for the inputs, and then it's going to compare it to the expected response, and then it's going to do some things behind the scenes of like actually trying to rewrite the prompt. And we'll come back to it. I'm getting ahead of myself a little bit, but we'll get back to that, and hopefully it'll make sense here in a little bit. So again, the very first thing we need to do is we need to create a function. So we're going to need a predict sentiment function. So predict sentiment. So we're going to say sentences. We're going to take those in as strings, and we're going to produce a string back. And we're going to say loaded sentiment prompt. And by the way, as we actually run this thing that MLflow does for the auto rewrite, it will actually write the version of what our new prompt should be automatically back to the same, like over like as a new version on top of like our original version. I know I'm a little bit jumbled with my words today. So that way we're not having to do like a manual re-registration of the new version, but we'll see that in action here in a little bit. So we're going to say ML load prompt, and then we're going to say registered sentiment prompt dot URI. All right, and then we're going to say formatted sentiment prompt equals loaded sentiment prompt dot format sentences equals sentences. And then we're going to actually get the response from the model equals OpenAI client. Dot chat dot completions create. My goodness, I thought that it never fails. I thought this was going to end up being a 45-minute stream, and now we're already at like the hour-and-a-half mark. It never fails. Model equals loaded sentiment prompt dot model config model name. Okay, messages equals role user. Content is going to be the formatted response, the formatted sentiment prompt, and then I'm not even going to worry about temperature. I have in my other notebook, but I'm not going to worry about that here. Response dot choices 0 dot message dot content. Might help if I have that correctly there. Dot strip dot lower. Okay, so that is creating the actual like prediction sentiment function here. Now here is where things start to get a little bit confusing. So behind the scenes, the way that this prompt optimization is working is using something called the JEPA optimizer. And basically the way I kind of understand the JEPA optimizer is that it's going through and using the current version of the prompt. It's going to try to predict the sentiment based off of those different sentences and do a comparison between the ground truth label and what was actually generated, and then if it looks good or not, then it will make the determination of yes, I need to do a rewrite of the prompt, or no, I don't. Now I even went over here and I started to ask ChatGPT of how this works. So JEPA, GEPA stands for Genetic Pareto Prompt Optimization, and so you can see this is a better explanation of kind of what I just stated, and that is it takes the current prompt, it runs predict sentiment over the examples, it scores outputs with equivalence, and I'm not entirely sure what equivalence here is. Maybe we'll ask that here in a second. It collects failures / feedback. It asks for a reflection to propose a new, better prompt, and we'll see kind of how that works here in a little bit. We evaluate the candidate prompt and keep it only if the score improves, and then register the best prompt as the new MLflow prompt. So that's how it kind of works in action. Now let's actually see how to actually set this up. So we're going to do another function here. We're going to say def propose sentiment prompt rewrite, and then we're going to take in a number of different inputs. We're going to say candidate, it's going to be a dict, string dict, reflective data set, it's also going to be a dict, string list dict. All right, and then components to update, it's going to be a list, string, and then finally what are we actually producing back is a dictionary, string. All right, now we're going to do a copy of the candidate, so we're going to do rewritten candidate dot copy. Oops, I'm sorry. Candidate dot copy. All right, now we're going to do for component name in components to update. Components to update. All right, so we're going to say rewrite examples equals reflective dataset dot get component name. Okay, and then this is what we're actually going to be writing here. This rewrite request. This is actually kind of informative to demonstrate okay, here's what the current prompt is, and here's what the feedback is. It's basically setting up a new prompt template to kind of determine what a new ideal prompt should look like. Okay, so this is going to take a little bit of writing here. I actually am going to handwrite this though. All right, so rewrite this sentiment analysis prompt to better match the expected labels. Keep the prompt as a text prompt that uses the variable. Now to escape variables, we have to do a lot of these curly braces here. So sentences, all right. And then new line, the only valid labels are positive, negative, and neutral. Return only the rewritten prompt template. Current prompt is going to be candidate, component name, and then optimization examples and feedback is going to be json.dumps rewrite examples indent equals 2. And then we actually need to invoke the model then to do this reflection. Response equals OpenAI client.chat.completions.create model equals OpenAI GPT-5.4 nano messages equals role user. I'm typing this super quickly. I'm hoping I don't make any silly mistakes. Rewrite request. Okay, and then rewritten candidate component name equals equals response dot choices dot message dot content dot strip, and then we are finally going to return this. Am I doing this on the right level? Yeah, okay, I am. Just making sure the indentation was correct. Return rewritten candidate. Okay, so that is the function that's going to help us do the rewrite. Now, how do we actually run this whole thing? Let's do that here in the next cell. We're going to take everything and put it all together, and then we're just about done here. So prompt rewrite result equals MLflow.GenAI optimize prompts. All right, so first things first, we need to give in the predict function. So we define that a couple cells above, equals predict sentiment. We need to give the training data, so that is going to be our sentiment rewrite analysis data set. We need to give the prompt URIs that we're going to be working with. So we're going to say registered sentiment prompt.uri. And then we need to, this is the thing that I was talking about before with the JEPA optimizer. So we're going to say our optimizer is going to be JEPA prompt optimizer reflection model. So this is how we actually have to call the gateway for the reflection model here, OpenAI. It's just as simple as applying this gateway colon kind of thing here. Max metric calls, we're going to just say 60. JEPA keyword arguments is custom candidate proposer. That's going to be the proposed sentiment rewrite result. Wait, it's this. Let me make sure I'm typing that correctly. All right, so this is basically just saying like, okay, we have a custom proposer of how we actually want to propose things that we define through that function above there. All right, so we need to pass that in as a keyword argument. What else do we need to do here? And then we need the scorers. It is bothering me that I don't know what the score is. Can you explain to me what the equivalence score is? We'll figure that out together. All right, what is the equivalence score? All right, it's basically asking, is the model's response semantically equivalent to the expected response? Okay. An exact match might mark that wrong. Equivalence can mark it correct because it is meaning the same thing. Okay, so it's basically saying, all right, if I'm not really sure how it's doing it, but you can see that if this expected is positive and the actual is the sentiment is positive, semantically speaking, these are the same. Syntactically speaking, they're a little bit different because we got a couple different extra words here in the actual, but they're about the same. But okay, so that explains that. So anyway, scores equals equivalence model equals gateway colon OpenAI GPT-5.4 endpoint, and I think that's everything we need to do. Now I'm going to go ahead and paste these things here at the bottom. Mostly these are just print statements for the result here, but then we can actually see what this actually does in action here, because we'll see a couple different things that are like logs and stuff as we go throughout here. This doesn't, depending on how you actually work with this, it can take a little while. In my experience, because we only have 20 examples and I'm using the nano endpoint, it's generally pretty fast. So this shouldn't be too much longer. And then we're coming up on the end of the stream here. We'll be done here shortly. So you can see that for at least for the first result that it's not proposing a new candidate. I'm hoping it does produce, like in my testing before, it actually did rewrite the prompt, and it did like, and so hopefully we'll see how that looks here in a minute. Okay, so it looks like with iteration 4, it is recommending new text for the prompt here. So we'll see here at the very end what the final candidate ends up looking like. And then we'll be done with this stream. We'll look at it in MLflow here once it's done registering. I don't know if I'm gonna have time to mow before lunch now. This went a little bit longer than I expected, but we'll see. Maybe I will. All right, are we still running? Dang, this is taking longer than I expected. I don't remember how long it took my... Let me check. I don't know if it'll show or not. So this is the original notebook that I worked out of. And I can't remember if it preserves... Yeah, it does not preserve how long it took to run these things. And that's okay. All right, let's go back. See if it's done yet. Okay, it looks like it is done. It took about 2 minutes there. And then, so let's actually go ahead and back up into MLflow here then. Go back to our prompts. All right, so this is our sentiment analysis prompt. And then you can see that, yes, it did. So let's do a comparison here. Let's do the text diff. So it changed pretty much the entire prompt. You can see that it has like a different like top level thing, and it's got different rules, and then it says return only one word. So again, that's the prompt, auto prompt rewrite in action. All right, I think that's everything that I want to cover today. So as what you can expect for the next one. So basically we started today with the AI gateway and the prompt registry, and then the other big side of using MLflow for generative AI is actually like using like building your own agents and then serving out your own agents and then capturing the observability and all those. And again, I wanted to touch on the components that we did today because you can imagine that the AI gateway and the prompt registry can support an agent. So we'll as part of our next stream, cover those observability features and by building our own agent, serving out, and then using the AI gateway as the backend for the model, and then also using the prompt registry as the backend for the prompt as well. So that's what you can expect for the next stream. I don't know if it's going to be one or two other parts yet for this next stream, for our next covering of this, but yeah, I think that's all I want to cover for today. I'm getting out of here. Hope you all had a good weekend. Hope you all had a safe 4th of July, and I will see you in the next stream.